All right, this is going to be a quick video walkthrough of the current calibration process. It's changed and improved quite a bit since the last time we did a video on it. So we're starting out with the machine is in a random configuration. It just turned on, the z-axis is at a random height, the belts are all random lengths. So the first thing we're going to do is we're going to click on alarm here to unlock the machine, and then we're just going to lower the z-axis all the way down. And we'll hear that bottom out. So that should be all the way down. Then we're going to click on setup here, and we're going to go into config. And this replaces the step where we had to edit files before. There's no more editing of files. We're going to enter our rough machine dimensions here. My machine is about 3,000 by 2,100. We're going to do this in the vertical orientation. We're going to run a 2 meter by 1 meter grid of 9 by 9 points. And this last value is just if when you press retract all, if some of your belts think they're fully retracted before they are, this sets the basically how hard it will pull when it's retracting the belts. So we're going to leave that. We'll press save. First thing we're going to do is we're going to press retract all, and that's going to pull all of our belts all the way in. All right, from there we're going to go to the next step, which is extend all. And then we're going to extend the belts. And it's really hard to just straight pull them out. You want to do like a rocking motion, and then it'll give you some leverage, and you'll be able to get them extending pretty easy. And then you just want to sort of pull with like a constant force until they'll turn off automatically when they're fully extended. All right, with the belts fully extended, we're going to hook it up on the frame. And then we're ready to press calibrate. So the first thing that's going to happen when we press calibrate is the machine's going to pull its belts tight and take an initial measurement. And it's going to use that to make sure the dimensions that we entered for the frame are roughly correct, within a few inches. And we do that now because basically we ran into issues where if the initial dimensions were completely off, it could get messed up. So looks like that was good. Now what it's going to do is it's going to run a 3 by 3 grid. And our initial measurements need to be within an inch or two. You can just tape measure it really quick. So now what it's going to do is it's going to run a 3 by 3 grid. And the initial 3 by 3 grid that it's going to run, it's going to move. You'll see as it moves between each point on that grid, it's going to use these two belts to move around, and these lower two belts will be slack. And that's how we used to do it the entire time. The problem with that is that they can end up spooling out too much belt, and that extra belt can sort of pile up and get stuck in the gears. The reason we do it that way, where we have the extra belt there that spools out, is until we know where the corners are, we don't know what lengths all 4 belts need to be as it's moving around. So it's going to do this initial 3 by 3 grid, then it's going to recompute, figure out where the corners are, and then it's going to use that sort of recomputed value to start moving around using all 4 belts. So after this 3 by 3 grid, we won't have to worry about there being extra slack on those belts anymore. So we'll let it finish that. There's also another advantage of doing this this system where we run an initial 3x3 and then we'll run a 5x5 around that, and then we'll run a 7x7 around that, and then we'll run our final 9x9. The other advantage of it is it helps the math converge, because basically each of those builds on the previous one. So we get an initial understanding, and then we refine that understanding, and then we refine that understanding, and we refine that understanding further. And so we eventually sort of target down on our actual exact anchor point locations. So it helps with keeping the belts tight, and it also helps with the math. So this should be our final point in our 3x3 grid. Basically, it's going to take this measurement, and then you'll hear the machine turn off, and it'll start computing based on the information it gathered in that grid. It's going to compute where our corners are. So we'll see that computing happen now. And this can take a while. One of the biggest things that I'm looking forward to improving on this system in the next version is I want to make it a lot faster. Basically, right now it takes too long to compute, and it also takes too long to take each measurement. I think both of those things can be sped up. We can also speed up moving between points as well if we want. But entirely, I think the whole process can be dramatically faster, which is exciting. Okay, so we've computed our anchor points, and now you'll see as the machine is moving around, it's doing so with all 4 belts tight. So we no longer have that concern of the belt getting stuck in the gears. So you can see, I'll watch as it moves to the next location. So this belt is now tight the entire time. There's no longer slack in those lower 2 belts. And if you were doing this in the horizontal orientation, basically in vertical orientation, it always uses these top 2 belts to move around, and the other 2 are slack. In the horizontal orientation, it switches which belt is slack depending on which direction it's moving. But the same thing would happen where after that first 3x3 grid, all 4 belts will remain tight the entire time. So now it's going to run a 5x5 grid. It's going to pause and recompute its understanding of the world again. Then it's going to run a 7x7 grid, pause and recompute its understanding of the world again. Finally, it's going to run a 9x9 grid. Again, pause, recompute its understanding of the world. Then it will move back to the center, and we'll be good to go. And this whole process takes a while, and I'm going to make it a time lapse. A couple things to note here. One, it can take like 20 minutes to compute, so don't be deceived by the fact this one just happened to go really fast. Again, we're working on making that faster. And second of all, you'll notice here that on one of these passes, my bottom left belt gets caught, and I just wasn't paying attention. So that's definitely not good, but be better than me. Okay, so the calibration process is now finished. We're back at the center. And something else that's nice about this new process is you don't have to restart, you don't have to enter anything. At this point, you are good to go. You can just start, using your machine and cutting right there. Yeah, there's still definitely bugs. There's still definitely room for improvement. We're going to continue to release new firmware every week, but it feels like we're making steady progress. Mostly thanks to incredible feedback in the forums, both in terms of discussions, people's ideas. Most of the things that have improved have been someone else's ideas in the forums. So thank you to everyone who contributed. And also just testing, just people telling us this doesn't work, this does work, this was better, this was worse. Yeah, so incredibly helpful. But yeah, we're going to continue to improve. We're going to make it faster. We're going to make it better. One other thing to note is that the process now improves on previous answers. So basically, if you run it and something goes wrong, and basically as it's moving around, it needs to be able to get a good reading on where its anchor points are in order to proceed to the next step. And so it can get stuck and basically say it's not safe to keep going, and it'll stop there. If you start the process over, it actually fixes itself a lot of the time because it builds on its sort of previous knowledge. Yeah, so we'll do another one of these videos next time we, have made substantial progress. Until then, we'll see you guys in the forums. Let us know if you have any questions.